This is the Math 3 Unit 4 PowerPoint review that we did in class. So there's 4 slides on the front of the paper that you were given and then 4 slides on the back. So this is slide number 1. So we're trying to simplify radicals. So when we look at trying to simplify something like this, I know the square roots of each of these. So that means my result will not have a square root. So I just need to go through and square root. So I know the square root of 25 is 5. And when I do square roots of my variables, I take half of the power. So half of 4 is 2, and then half of 6 is 3. So when I do this, I just have 5x squared y to the third. And so here, when I have an x squared, and if I had 2 negatives, it would still be positive. But on this one, if I had 3 negatives, that would be negative, right? Odd negatives make a negative number. And so because here this is telling me it's positive, because an even, then I know this has to be absolute value. Okay. So just a little reminder, right? So the square root of x squared would be the absolute value of x. Okay. The square root of x to the 6th would be the absolute value of x cubed. Okay, and that's because 2 negatives make a positive, but only 1 negative would be negative, so I need to force it positive. 6 negatives would be positive, but 3 negatives would be negative, so I have to force it positive. Okay, and so on and so forth. Okay, so for question number 2, the square root of 20 I don't know, and I don't know the square root of y to the first, but I can't even split off a y. So I'm going to rewrite my problem, 3xy cubed. 20 is 4 times 5y. And then I don't know the square root of 5 or the square root of y. So I'm going to write that always first so I don't mess that part up. So these are what I don't know the roots of. So when I take the square root of 4, that gives me 2, and I already have a 3, so I'm going to multiply. So root 4, so 2 times 3 is 6. And then I still have xy cubed. Okay. So when I'm multiplying, if the numbers are small enough, I always want to just go ahead and multiply first. If they're larger numbers, I would simplify first. So there's an implied 1 here, so I'd multiply the rational numbers first, so 3 times 1. And then I'm going to multiply 2 times 10. And then x to the first and x to the first. I have 2 x's being multiplied together, so x squared. Y to the first times y to the fifth is y to the sixth. I have 1 y and 5 more, so altogether I have 6 y's. So now when I square root this, I'm going to split up 20 to 4 times 5. And then I don't need to break off one of the values here because I have even powers. So the only thing I don't know the square root of is 5, so I'm going to write that first. And then I'm going to take the square roots and multiply it to whatever else is out here. So I have the square root of 4, which is 2, times 3 is 6. Taking half of the powers, so that'd be x to the first, y to the third. So I would have 6xy cubed root 5. And then I'm not going to have any absolute values because I have no x squared or y to the 6th up here, right? So here for adding and subtracting, I always need to make sure that this part is exactly the same. So I have a 32x versus an 18x cubed. So at this point, I can't actually add it. But if I try to simplify it first, maybe they'll have the same radicand. And if that's the case, then I can add. So 32 seems to give us a lot of trouble. So when we try to think of factors of 32, we know 4 times 8. And that's usually the first one people come up with because they know the square root of 4. But 8 can actually break down again as well. And so we don't want to use 4 and 8, we want to use a bigger factor. And so for 16 times 2, that's my largest factors. So that's the numbers I want to do because I can take the square root of 16 as well. So I have 3x. 32 is going to be 16 times 2x. These are the ones I don't know the root of. Plus, and then I have a 2. 18 is 9 times 2. And then for x to the third, I'm going to split off one of the x's. And I don't know the root of 2 or the root of x. So I'm going to put my root first so I don't make that mistake. And then the square root of 16 is 4, and I'm going to multiply it to 3x, which is 12x. The square root of 9 is 3, times 2 is 6. The square root of x squared is x, and then I don't know the roots. So when I'm adding this, I'm thinking of, I have 12x plus 6x. So I'm adding my coefficients, so that gives me 18x. And it's not going to be squared here, right? Because this is saying I have 6x's being added, 12x's being added, so I have 18x's being added. And if I wrote this as a squared, that's implying somewhere over here I have some squareds in the problem. And then for adding my radicals together, they should not change. It should still be 2x. Okay, for question number 5, I want to distribute. So I'm going to multiply 3 times 4, and then also to the root 5. So I'm going to multiply 3 to both of these. So 3 times 4, and then 3 times the negative, and there's an implied 1 here, so 3 times negative 1, and then just root 5. So I don't want to multiply the 3 and the 5 together, right, because I have a rational number with an irrational. So 3 times negative 1 root 5 is negative 3 root 5. And then I'm going to multiply these two together. So I'm going to multiply 2 root 5 to both of these. So again, I'm going to multiply the 2 times the 4, positive 2 times positive 4, and then I just have a root 5. And then multiply these together. So 2 times negative 1 is negative 2. And then when I have like radicals being multiplied together, that just turns into 5. So that would be the square root of 25, which is just 5. And then I can combine my middle terms. So I have negative 3 plus 8, and then keep the radical the same. And then 2 times 5, or negative 2 times 5 is negative 10. And then 12 minus 10, I can combine those two integers together, so that would be positive 2, and then plus 5 root 5. And then I cannot add the 2 and the 5 together, right, because I have to be able to multiply before I can add. Okay, so for question 6, I'm dividing, so I'm going to rewrite this as 3 over 6, and then I'm going to put this all under 1 square root. So 3 divided by 6, that's just 1/2, right? So I can divide by 3, which is 1, divide by 3, which is 2. And then divide here, so 45 divided by 5. And then I have 1x and 6 up here, so that's going to reduce one of these away to give me x to the 5th, so I'm just subtracting my powers. And then I have y squared divided by y to the 1st, so this will reduce one of those away, leaving y to the 1st. And then now I have to split off one of the x's here. 9 is good, right? I know that root. So that would be x to the 4th, x, and then y. So I don't know these two. So the square root of 9 is 3. Square root of x to the 4th is x squared, and then I don't know the roots of those. So as far as the 1/2 times 3, I'm just going to put that over 1. So then my final answer will be 1 times 3 over 2 times 1, and then x squared root xy. Okay, so slide 1. Okay, let's take a look at the next one. So this is slide 2, so transformations. So we want to write the equation for the graph translated right 3 units and up 5. So because I'm going right, this is going to affect the x, right? So I'm going to change my x value. Because I'm going left or right, it changes my x. And then up 5 units, so that's up or down, so that's going to change my y. So in general, they're telling me this is my parent graph. So I know that I have y minus k equals, and normally there's an a here, but our a is 1, square root of x minus h. So if I'm going to go right 3, then that means this should be x minus 3, because if I pull that out, right, to zero it out, that would be a positive 3, which would move me right 3. And then here, if I'm going up 5, same thing, so it should be y minus 5, because if I were to pull that out, that would be positive 5, right, to zero it out, so positive 5 would move me up 5. And so there would be my transformation. For number 2, we're looking to describe the transformation. So when they say describe, they want you to say things like left 5, down 7, or something like that. And we're going from F to G. So I'm going to rewrite this into standard form, or into vertex form. So I'm going to subtract the 3 over. And f of x is just the same as y. So my vertex for this one is negative 2, positive 3. And then for g of x, so that's for f, so g of x is the same as y, so I'm going to add the 2 over. And so then for g, my vertex is positive 1 and negative 2, right? So we do opposites because we're just zeroing it out. So 1 minus 1, negative 2 plus 2. So I could do a little sketch to kind of figure that out also. But before I do the sketch, I'm just going to try to figure out my movement. So if I'm at negative 2 and I go to 1, that's in a positive direction. And these are my x values. So I'm moving along the x-axis. So I'm going from negative 2 to positive 1. So I know I'm going to be headed right. And then along my y-axis, I'm at 3, and I'm headed to negative 2. So I'm at 3, headed to negative 2. So on my y-axis, that means I'm going down. So I'm just going to graph these. Negative 2, 3. There's where f is. And then over 1, down 2, there's g. So I don't have to graph it, but sometimes the visual is helpful. So I'm going to the right, so 1, 2, 3. So I'm going to the right 3, and then count to go down. So 1, 2, 3, 4, 5. So I went right 3, down 5. Okay, so if I go negative 2 plus 3, that puts me to 1. 3 minus 5 puts me to negative 2. Okay, and then that's it for the first 2 slides.